everyone, this is Matt from In Defense of Plants, and we've made it to the Cascades. I'm so excited for the adventures that are going to come, but already I'm seeing some incredible species, so come on, let's go see what we can find. This right here is one of the most remarkable trees you're going to find in the Cascade Mountains. This is the western red cedar. It's not a true cedar, of course. Those only occur in the Mediterranean regions. However, this is still an impressive species. It reaches epic proportions in lowland moist forests, but it can also be found in drier forests all the way up to the mid-elevations. It is a cornerstone of the ecology of this region, and people have relied on it for centuries, if not more. It is a remarkable tree, and it's telling me that these low elevation forests are going to reveal some great finds. So let's move on and see what we can find. This is a really exciting find. This is a buckthorn. Now, where I'm from in the east, buckthorn are super invasive. They've crowded out a lot of native habitats, but here, this species in particular is native. How cool is that? This is Rhamnus persiana, and it's a decent sized tree actually. Most of the canopy of this is arching all the way up to about mid-level of the understory, but it's a remarkable tree. And what's not to love about a native buckthorn? It's producing large berries, which again probably feed lots of different animals, and it's a nice broadleaf species that contrasts well against the dominance of conifers in this ecosystem. Check it out, it's a red huckleberry. I was wondering when we were going to meet this species. It is one of the more common shrubs you're going to find in the forests of these lowland areas. It's super easy to identify because it's got this beautiful foliage arrangement, and its stems are so angular that they appear square. It's actually a cousin of the blueberries. It's in the same genus, Vaccinium, and as far as I know, it's the only upright Vaccinium that produces red berries. As you can imagine, these red berries feed a lot of different animals. Now, to find this species in the wild, look in places with humus-rich soils. These will often grow in moist, decaying logs to the point where you can actually find them in old stumps or growing up on branches of larger trees where enough detritus has developed. And they're edible. The Pacific Northwest is a land of conifers. Indeed, the Cascade Range is no exception to this rule. Their success in this environment over the hardwood species we see scattered about the forest has everything to do with the climate. This is an area punctuated by long summer droughts, and drought really favors plants that are better at their water use efficiency than others. And indeed, conifers are really water use efficient. They have small, narrow needles that they hold on to year after year after year. Another benefit that conifers have over hardwood species is the fact that they're evergreen, they're not deciduous, and the mild climate around here means that they can photosynthesize throughout much of the year, whereas the deciduous species really only get the summer growing season. We're going to meet a lot of these conifers on an individual basis, but it's worth noting that the climate really favors these species over the hardwoods. Now I'm standing here next to one of the more common conifer species that you're going to find in the Pacific Northwest. This is the Douglas fir, although it's not a true fir. It's in the genus Pseudotsuga instead of Abies. It's readily distinguished by its cones, which have these bracts that have been likened to little back ends of mice hanging out of each cone scale. Their longevity is incredible. These live upwards of 1,000 years in the right kinds of condition. And what's amazing is that they can establish in different kinds of habitats. They can live in lowland dry areas and montane moist forests, and they get huge. Their bark is incredibly thick, which makes them extremely resistant to fire. So a lot of the Douglas firs that you see in old growth forests established after a fire event many centuries ago. It's an incredible plant and one that barely reaches its full extent outside of this beautiful Pacific Northwest climate. This right here is something really cool. This is Acer macrophyllum, or the big leaf maple. Acer macrophyllum hints at the size of these giant leaves. And one of the coolest aspects about this tree is the fact that it carries one of the heaviest bryophyte loads on its bark and limbs than any other tree in this region. And in fact, it was only recently discovered that that bryophyte load can grow so thick and hold on to so much moisture that the branches will actually put out roots of their own, effectively doubling or even tripling the amount of root surface area that this tree has to survive. What's cool is that as different debris and things start collecting in that moss and breaking down, it forms its own type of soil, which probably supports myriad insects and other microorganisms that can live in this forest now thanks to the extra surface area and habitat created by this tree here. Now, as I mentioned, this area experiences regular summer droughts. So much so that the only form of water that plants get throughout much of the summer, especially later into the summer, is from snowmelt and glacier melt farther up the mountains. This is troubling as temperatures continue to rise and droughts get more and more severe. Snowpack is melting way earlier, and glaciers, of course, as we know, are disappearing, which means dry creek beds like the one I'm standing in right here are going to be more common. And this is especially true at lower elevations where those water subsidies from farther up above are super important. Who knows what's going to happen? Again, weather is highly variable, but on average, things are only going to get warmer and drier in this neck of the woods. Hey, check it out, we found our first orchid. It's a Goodyear orchid, probably Goodyear obtusifolia, and it's in flower right now, although it's not large and showy like some of the other orchids you might see in this region. Nonetheless, it's a great little species, really enjoys acidic soils, so this pine litter that's coming down from above, perfect growing medium. Like all Goodyear, they throw up these rosettes of leaves that have this beautiful lightning-like veination to them, which they think is an adaptation to absorbing as much light as possible from these shaded forest floor communities. These flowers will be visited by a wide variety of pollinators. Bees are probably the most effective, but this is an exciting species to find, and they're clonal, so you usually find more than one in any given area. Once a flower stalk is done flowering, that individual rosette will die, but then new ones will pop up, and with any luck, it's set seed and sending thousands of seeds out to start potentially the next generation. Great find. Now this is a new one for me. This is ocean spray or cream bush, and the wood of this species is extremely hard. In fact, it's so hard that they used to file pegs out of the wood and use them as nails in construction. Pretty remarkable for a little shrub growing in the understory of this Cascadian forest. Really exciting find because I didn't think we were going to be able to see these in flower this time of year, but down here hidden among the ferns is the Pacific bleeding heart. And believe it or not, like all members of this genus, they are a member of the poppy family. Highly derived flower morphology that's all about getting exclusive pollinator access to bees with long enough tongues. This one is just finishing up, and you can even see some of the seed pods developing on the flowers themselves. Delicate little plant, but seems to really enjoy these rich, acidic mountainsides. This beautiful little tree right here is the vine maple. It's a relatively small tree, especially in comparison to the trees that it shares this forest with, and because of that it tends to hang out in the understory. Now, one of the most interesting things about this species is the fact that it serves as a reminder of the land bridge that once connected Eastern Asia and North America. You see, this maple right here is more closely related to the Japanese maples that you would find in garden centers than it is the maples that you find native on the east coast of North America. Nonetheless, it's a beautiful species, and like the maple we saw earlier, this too will form aerial roots off of its stems and branches if enough moss builds up. It's a great plant to see. Guys, it's the candy stick plant. It's past flowering, but I don't care. You still get the idea. This is an awesome parasitic plant. It's living on fungus that is partnered with the conifers around here. So it's an indirect parasite of the trees, and it is gorgeous. It's a strange member of the heath family related to the ghost pipes that you see back east. In fact, they're probably native here too, but this one is just absolutely spectacular. Look at these fruits. They're deep purple, and then the stem is what gives it its name. It's red and white striped like a candy cane. I have always wanted to see this plant, and I'm so jealous of people when they post pictures, and here it is. This is a good day. Check it out, it's sword fern. I have wanted to see this species in person for so long. It is one of the most dominant species in the Cascade range, and indeed throughout the Pacific Northwest. And it's been made famous the world over thanks to movies like The Lost World and the Star Wars series. Now, this is a huge fern, and it's rather robust. Its fronds are evergreen throughout the mild winters, and you can see across the landscape it's doing so well. Despite how dominant it is and the fact that it puts out tons and tons of spores, at least as soon as 2015, we have not yet described the gametophyte of the species, which is kind of odd. Nonetheless, it's a beautiful plant, and I'm just going to wallow in it for a while and soak in this wonderful experience. So mixed in here are two other understory species that are quite dominant in this landscape. This first one here I've known since I was a little kid. I used to think these were hollies, but they're not. They are the Oregon grapes, Mahonia, and I believe this is Mahonia nervosa. It's a small sort of subshrub and quite spiky. Now, sometimes this is known as berberis, and it's another one of those species that has far more representatives over in Asia than it does here in North America. And behind me here, we have another of the dominants, although this is in a different family. This is Gaultheria salon. This is from the family Ericaceae. It's another ericoid. And it is a dominant understory species because it is rhizomatous. It throws underground stems around and can pop up everywhere and anywhere. It is so thick that it is said to hobble most things that are trying to run through the forest at high speed. It gets these very sticky berries coming off of a very sticky inflorescence. It's an interesting plant, and again, completely new to me.
Amazing swiftness, the quiet enclaves of north-central Washington have been transformed into staging areas. The solitude of a vacation wilderness has been broken.
Fire is a natural component of the forests of the Cascade region. For instance, the one behind me burned through here back in around 2008. Now, life is starting to return to this area. The surrounding is completely littered and totally alive with wildflowers. However, as droughts grow longer, as temperatures get warmer, fires are only going to get more intense. Really hot fires burn the landscape and actually sterilize the soils to the point where what comes back certainly isn't what was there before. We have mismanaged fire in this country for over a century, and we're starting to pay the price. Fuel loads are at the highest they've ever been, and fires are getting much worse. As we speak right now, Oregon is ablaze with wildfires, as are many other places around the globe, and things are only going to get more intense from here. It's unnerving, but we have to get better at how we manage fire on this landscape. As you can see, we've made it to the tree line. This is where conditions are getting a little too harsh for trees to continue to live. Any farther up the mountain, you're getting into subalpine vegetation. However, as our climate continues to warm, this becomes a battleground of sorts. When conditions get warmer throughout the year, trees can move farther and farther up the mountain, which pushes sensitive alpine vegetation that can't handle shading farther and farther up the mountain. And if you look behind me, once you get to the top, there's really nowhere else to go. This is called the alpine squeeze, and that's why the peaks of the mountains, these sensitive alpine areas, are in so much trouble as our climates continue to warm. With any luck, we're going to see a lot of cool stuff today, and it's really important that we capture this stuff now as it stands so that we know how much it's changed into the future. So come on, let's go see what we can find. I'm extremely honored and privileged to be sitting here in the presence of this species. This is the white bark pine, and it is a cornerstone of this subalpine ecology. Its seeds offer food to tons of wildlife around here, from ground squirrels to Clark's nutcrackers and even grizzly bears. Without this tree, a lot of those species simply couldn't live up here. The sad part is that this species is on the endangered species list. Alterations to fire ecology, the pine blister rust, and even the pine beetle are taking its toll. In the western Cascades, it was estimated back in the mid-2000s that upwards of 40% of this species has been lost, and that's super alarming. It serves as a very important reminder of the speed at which humans are altering this alpine ecosystem. If this species were to disappear, this ecosystem would not be the same that it is today. Subalpine meadows like this are very special places. They're usually the most biodiverse regions on the mountain because trees like these mountain hemlocks are still growing tall enough to create perfect little microclimates that support a higher diversity of plant life. What's more, they're fed by snowmelt. And the different levels of which snow melts, depending on the north-facing slopes or south-facing slopes and everything in between, dictates what kind of plants can establish themselves here. And then again, when you think about climate change and the speed at which snowpack is staying around less and less, that changes the kinds of plant communities that are going to maintain themselves in these meadow ecosystems. So these dynamic places are the ones that are feeling the effects of climate change the fastest. One of my favorite things about alpine vegetation are their size. They're always small and hugging the ground. They do this because they're so exposed up here. There's not a lot of things to block the wind, and anything that grows any taller than this is just going to be knocked down. So like this little pussy paws here, it's hugging the ground, this tiny little rosette of fleshy leaves. The soil is kind of sandy and granitic. It's not holding on to a lot of water, but nonetheless, this thing is thriving, it's flowering, and what's cool is its seeds may be only a few inches off the ground, but they're really lightweight and winged, and so they blow away on the slightest breeze and get wedged in nooks and crannies where they can be sheltered and grow again. I just love alpine vegetation. So the higher you get up, the harder things get, and even the trees start acting like cushion plants. You can look at the surrounding vegetation here and see that most of it's hunkered down, but even this little spruce or fir here that's trying to establish itself can only really grow in this nook and cranny between these two rocks where the wind isn't going to hit it too hard. And I guarantee you, as this tries to grow taller, it's just going to keep getting wiped back. It's almost like a bonsai being made by nature itself. And even in this valley, as you look up, this is very unstable material, right? This is all stuff that gets washed down at the end of each winter. And I don't doubt that at one point, the glaciers that were up on top of Mount Hood were once all the way down here. And this is already starting to become revegetated to some extent. But the constant erosional processes mean that this reset button is constantly getting hit. And that's what kind of maintains this area for these lower growing herbaceous communities. This is just a remarkably alien landscape if you're not used to it. Check it out. How cool is this? This is a miniature lupin. This is the dwarf mountain lupin, and it's doing another great impression of an alpine plant. It's got small, cushiony growth, very hairy leaves to reduce on evapotranspiration and all of this intense solar radiation that's coming in. And check out these inflorescences. If you stand back for just 10-20 minutes, these things are covered in what few pollinators are up here. And I kind of get like a little bit of a grape smell off of them. It's very pleasant and adorable, to say the least. So the harsh mountain conditions means that some plants have gone to other means to get food and water. One great example of this are the paintbrushes in the genus Castanea. This is just one of them. They come in many different shapes and colors. But the cool thing about this is that it's a hemiparasite. Now it still has green leaves, it's photosynthesizing on its own, but its roots tap into the roots of the surrounding vegetation and steal things like water. That means they can live a lot better than some of the other plants when things start to get really rough and drought becomes apparent. But this isn't the only kind of parasite we're going to see in this mountain range. There are others around, and with any luck, we're going to find some of them today. And right here is another one of those parasites that I was talking about, although I wasn't expecting to find this particular type of parasite, and I'm really happy we did. These are coral root orchids, and they are 100% parasitic, although they're not directly parasitizing roots. These instead are parasitizing mycorrhizal fungi that are connected to the roots of these conifers around here, so they're indirect parasites of trees. They're usually in low biomass. I don't know why the fungus doesn't detect them and just cut them off, but nonetheless they are gorgeous. They don't have chlorophyll in them. They're kind of burgundy, pinkish red. They have these highly decorative lips, and they're an orchid. What is not to love about this? So again, the harsh conditions of this mountainous habitat has led a lot of plants into producing structures that help them steal nutrients and water from other plant species. So right here is one of my all-time favorite cushion plant species. This is the sulfur buckwheat, Eriogonum umbulatum, and it's a species, or at least a group of plants I have not seen in many, many years. But look at this growth form. It's got very small, hairy leaves, again, keeping it low to the ground, sheltering it from the punishing winds and the punishing UV rays, and only puts up enough biomass to get its flowers up where pollinators can find them and wind can eventually disperse its seeds. But the most interesting factor about this is look at the structure of what's going on right here. Not only is this plant growing in one of the harshest conditions it could possibly be growing in right now, but its roots and the fact that it's covering and hugging the soil so tightly have created a mound where wind is blowing around and eroding the soils beside it. So these, in a sense, are kind of ecosystem builders. They've established themselves here, and other plants are even starting to take root in and amongst them. It's a fascinating process, and one that really happens in these super exposed alpine environments. I think I've just found one of my all-time favorite alpine plants. This is a tiny alpine carrot. I believe it's in the genus Lomatium, although it might have changed since the days when I was doing any work in the alpine zone. But this little thing is everything you want out of a carrot. Tiny dissected leaves, a beautiful umbel of yellow flowers, But the funny part of it is that it doesn't throw up its flowers as high as other cushion plants does. It still sits almost flush with the ground. But what it does do is that after the ovaries have been fertilized and the seeds are mature, the seeds actually stick up farther than anything else on this plant, and they're extremely winged so that the slightest mountain breeze can take them away, and then hopefully they'll roll into another nook and cranny where this little plant can then continue on the next generation. This is such a cool find. I am so excited by this plant. This is an awesome sight to see because we're getting to the point where we're really pushing the limits of what plant life can handle in terms of elevation on a mountain face. We have our old friend here, the dwarf alpine lupin. We have an interesting looking rush that I simply can't identify, and a penstemon just going over from flowering. These guys are still doing great despite the harsh climate. And it's interesting to think about what really limits plant growth up here. It is a punishing environment, but more and more research is showing that alpine plants like this can actually handle the heat that comes with accelerated average temperature warming. However, what ends up happening is that species from lower down the mountain, especially invasive species, start making their way up here. It's not an all or nothing situation. Different species are going to do it in different habitats, but it's the difference in competition that comes with these new arrivals to higher elevation areas that is really troubling for alpine plants like this, because, like we said earlier, that elevational squeeze as plants get pushed up to that peak pushes them far beyond the limits of what any sort of living creature or organism can handle. And eventually, species like this may just get pushed right off the top of the mountain and have nowhere to go. Behind me you can see one of Mount Hood's many glaciers. Like glaciers around the globe, this one is retreating at an accelerated rate. Because the warmer months of summer mean less snowpack on the mountain, there's not enough to keep this ice from flowing down into the valley. And remember, it's the snowpack and these glacial meltwaters that feed the forests with water throughout the droughty months of summer. As these disappear, so does that hydrology, and thus we'll have ripples throughout the entire ecosphere. It's a sad reminder, but one that reminds us that we have to act fast, and we have to act now if we're going to change this trajectory that we're on.